Hello, I'm Stephen Forrester, the principal engineer of DMA Engineering. We were recently talking with the client, and they had a lot of questions about why solar and air source, and more particular ground source heat pump systems, is why there's such benefit to doing that. So we had a discussion about it. I thought it'd be great to have something out there that people could use as somewhat of a reference. So that's what this presentation is about. So why is solar better with electric heating using air or ground source heat pumps? So it really comes down to, in a nutshell, you want to consume the energy that you're producing on site, right? So a heat pump will consume electricity by using the refrigeration cycle. We have a video on our website about ground source heat pumps and how they work. And then we also have another one about electric heating that goes into the nuances of both. So I would encourage you to look at those because they'll help couple exactly how an air source or a ground source heat pump system works. So I'm not going to dive too far into that. The main thing about it is that on site, electrical energy will be consumed on site. Well, currently with the forced air furnace or a boiler for your radiant system, that's using natural gas, and then everything else is using electricity on site. When we go to a heat pump, your heating is all done using electric heating. So we get electric heating currently from fossil fuel power plants, or grid, wind energy, solar energy, nuclear energy, and also natural gas power plants, which are fossil fuel, and coal-fired power plants, which are fossil fuel. But if you were to do solar on site on a residence or a building, you're consuming exactly what you're using. Now, electricity, if we would think of a furnace that's just burning gas, those are about they have a COP, a coefficient of performance. So it's work out versus divided by the work in. So in a gas fired furnace or boiler, high efficient is about 0.9, has a COP of about 0.9. 0.9 to 0.95 is pretty standard. When you look at a heat pump, an air source heat pump is going to have a COP that's in Colorado, the Front Range is about 3. And with a ground source heat pump system, you're going to have that at about 4 to 5. So there's a bigger COP with that. Now, when we look at the economics of all that, natural gas is the cheaper fuel on site. So the economics play in that. But the key is that there's energy coming in either from a fossil fuel power plant generating electricity or solar on it. So it's all consuming electric heating. So is what we did for this presentation is we have this building here that we kind of use is just our standard. This one, we modeled this building. This house was never built. This residence was never built. So this is the one we use because we have some data. We have a model set up and we just play around with this one a lot. So this is the model. So we just modeled this system with the gas forced air furnace and an air conditioner compared to a ground source heat pump system. I didn't do it to an air source because it was just and more data points, but really you're going to get the feel of exactly what's going on here between the two, or at least I hope you do. So what we did is we did a net present value of a ground source heat pump system here. Again, we ran the model, so we get the energy consumption between the furnace and the AC unit, which is your standard air conditioning unit, and then a ground source heat pump system, which we're just labeling here as a geo unit. So geothermals are the other way. You hear a lot of people talk about ground source heat pump systems. And then we just did a net present value of that system. So as you can see, the baseline building has a higher net present value than the ground source heat pump system. Even though the capital cost of the ground source heat pump system is $15,000 more than the gas-fired furnace. Now, this is a very generic type analysis, if you will. So the numbers will vary because we're really only comparing equipment to equipment and the cost of the ground heat exchanger with the ground source heat pump system. So that's kind of where this payback is coming in. So here's the ground source heat pump system with like we were just talking about, and it has a 16-year payback. And that's pretty common about what we see. Sometimes they can run out a little bit longer to 19 years. But 16 years is about what we see typically with it. Now there is tax credit available, and that's what the lower slide here is showing it with the taking advantage of the 22. So in 2022, it's 24%. In 2023, it's going to drop to 22%. And then after 2023, we do not know what's going to happen with it. That's all a political football. So we'll have to see what happens with that. But taking that into account, we get a 9-year payback with the ground source heat pump system. So that I think that's one big thing, right? A 9-year payback is shorter than the length of the equipment. So that's a big deal right there. The other thing to notice is the baseline, which is the gas-fired furnace and air conditioner, has a significantly more carbon production than the ground source heat pump system. So if that's something that you're trying to do is reduce your carbon, well, there's the proof in the pudding right there. You're almost it's almost a factor of 3. It's more like probably like 2.8 carbon reduction, right, against the standard air conditioning system. So then we look at it, just the solar photovoltaics. Now the size of this solar photovoltaic system is just enough, its size just to offset the electrical consumption of the ground source heat pump system. Now, if it's an air source heat pump system, because the COP isn't as good, it's not as efficient as the ground source heat pump system, it's going to require more solar photovoltaic to provide the same amount of electricity offset over a year's worth of production of the solar photovoltaic system. So that's going to be it. And I just noticed solar photovoltaic is not right in the slide, and I'm not going to fix it. So sorry about that. But anyways, so this is just the energy to do it. It's not the whole residence. It's just the heating and cooling energy consumption is what we size this solar system to be to do that. So if you look at it, the net present value payback of this system is 24 years. But there's no carbon production, right? So if you really want to go after the carbon, this is the way to do it. Again, solar also has the same tax credit as the ground source heat pump system. So if we take that, 22%, this is modeled for 2023. So we're doing the 22% on this modeling here. It's a 13-year payback, right? So here they are, standalone systems on their loan is we're comparing. Now, if we couple them together, right? So we look at the payback analysis of everything with the cost of the geo and the solar mixed together in one. We have no energy consumption on site on an annual basis. It brings this payback down to 16 years combined, right? Where I think the solar was 24 in the previous slide, and the geo was 16 on its own. So it makes them both come down to 16, no carbon production. You definitely have a bigger capital outlay, but you're going to have it, there's just no way around that. Take advantage of the tax credit on both of those together, coupled as a system, and we're at an 11-year payback. So the solar on its own was 13, and the geo on its own was 9. Couple them together, we get a 9. So I think that right there is the story: is that we're shorting the payback between the solar and the geo when they're coupled together. So yeah, what does that all look like? So here's a couple, this kind of combines everything together. So the geo on its own has a 16-year payback with the 22% tax credit. It's at 9 years. Solar, no tax credit, has a 24-year payback, but solar with the 22% tax credit is a 13-year payback. You look at the geo and solar without a tax credit to combine, they're 16. So right there, whatever happens with the political football, you got a 16-year payback. That's great. Better yet, you take advantage of the tax credit, you're looking at an 11-year payback. And with everything with the geo and the solar, there's no CO2 emissions being produced on site. So that's why when we do air source and ground source heat pumps and coupling those with solar on site, we reduce the CO2 emissions on site. That's the big advantage of it. If you were to have a gas-fired furnace and put solar on the building to offset the air conditioning load and the building's other electrical loads, you're missing out on reducing the CO2 produced by gas. I mean, you'd have to you could put it on there, but really the only way to offset the CO2 produced by burning gas is to plant trees like in Brazil or something, right? So you got to do something else to make that happen versus, just actually offsetting what you're doing there on site. So that's the net advantage of that. So, all right, well, so key takeaway, solar has a lot longer payback on its own, coupled with electric heating shortens the payback. Tax credits make payback quicker, offset electrical energy consumed at the source, resident, or building. And because you're doing that, there's no carbon production on site, right? So you're kind of being that responsible person about the CO2. When we get into requirements where we got to meet code, right? Got to be net zero. Boulder, we have 2 projects going on in Boulder right now that they need to be net zero because of the size of the homes. There's no reason why a homeowner shouldn't be able to build the house that they want, and all the creature comforts of what they want into that residence and still be net zero. I mean, we can do it. The technology's there. Just really comes down to the will. Hopefully more people will want to do it instead of being forced into it by code. So let's hope there's a trend that's going to be started by this. The state code here in Colorado, energy code, is going to make things happen anyways. And Denver's going electric heating. So you can be an earlier adopter and get on it. So anyways, I hope you found this a lot informative. I left out a lot of things. The net present value is something that we do on almost all of our projects where we'll do some type of trade-off analysis, whether that's between the building envelope, the mechanical system costs, and the solar photovoltaics. There's a lot of mix that go into a residence or a building, and you really need to look at it holistically and understand the financial aspects of one versus the other. Because if it's done correctly, things aren't as expensive as people think, and having a 9-year payback on something, or even a 13-year payback on something that you're going to put into your residence, there's nothing you can really put into your house other than the HVAC and the renewable energies that will actually pay for themselves. You could argue that something, the granite countertop could raise the value of the home, but that's all subjective. This actually has a payback to it. So I encourage you to think of that on your projects. So I hope you found this to be informative and got something out of it. So again, reach out to us if you want to talk about more about the things you can do to make your residence net zero and the advantages of better windows over HVAC systems. There's a lot of things that go into that. Anyways, look for more videos coming out for us. I'm going to try to produce one video a month, going into a little bit more of this stuff. So keep an eye out for these videos as we go along, and take a look what's on our YouTube channel for the videos we have now. Thanks for watching. Hope you got something out of it.